Silicone sealant in the workshop, part 1. I use silicone sealant infrequently because in the past I have had problems with fragments of the silicone getting into the valve chest and holding the valves away from the port face. Here is the first instance of this particular problem. When the particles of silicone rubber prevented the valves in the water chest from working properly in this Southworth Engines duplex boiler feed pump, which is very well made. I fed some compressed air into the pump to see what happened. Nothing happened. And did I expect anything to happen? No, because at some stage someone has sealed this with silicone rubber. Now, silicone rubber is a very good sealant. I don't have any of it in my workshop at all. I use it in my bathroom. Well, now and again. I use soap most of the time. The problem is, it tends to ooze out on the outside and it oozes out on the inside. So when you first fit the silicone rubber, internal parts work fine, but then when it goes hard, they stop working, and this is what's happened. The valves are all gummed up with silicone rubber. I can't prove this, but in a moment I'm going to have a look inside the valve chest, and I think you'll find that that is the problem. No matter how fast the pump goes, it's not pumping hardly any water at all. I think there's a tiny bit coming out of one side. The main pump rods on the pump are a little bit dry, so I'm just giving them a bit of lubrication, and this will make the pump put a little bit more pressure on the valves, as the valve rod seal is much better with some oil. And a short while after applying the oil, all of a sudden some water starts to come out of the bypass pipe. Not a lot, but it's better than nothing. Time to look in the water chest, I think, and see what the problem is. It's really stuck fast. You must never ever use silicone sealant for steam engines. This took ages to get this off. It was so firmly stuck. And once I got it off, can you see what the problem is? Look, the stuff's everywhere. It oozes outside and it oozes inside. Only one of the valves was loose. The rest were gummed up with silicone rubber. One of the valves was loose. The other two needed a screwdriver to get them to move. And the fourth one was nearly impossible. I had to use a pair of pliers to get this out. It was so firmly stuck. Anyway, I got them all loose, and I thought what I would do is use some T-cut just to make sure that they seat properly on the seats. With all of the valves moving freely, I refitted the water chest cover. I didn't use a gasket because there's still a layer of silicone rubber on the actual metal, which should do the job. At least it's not going to ooze all over the valves. I'll see how it goes. If it leaks, I'll have to scrape it all off, which will take forever, and I'll fit a gasket. When I put some air into the pump, water starts to come out of the bypass valve, and it's water that's under pressure, so the valves are working. When I try and block it up, I can't, so it will pump against boiler pressure, and it's not 100%, but it's better than it was. I think there's some air getting in somewhere. Before I finish the plant, I will be going around it and making sure that all of the union nuts are fully tightened. It does need some gaskets, really, so I'm going to make some. I'm not going to use silicone rubber, perish the thought. Instead, I'm going to use some of this. This is brown paper for wrapping presents and parcels. I've shown how I make gaskets for model steam engines many times, normally using gasket material, but this brown paper is a bit thinner. The principle is the same though. I use the ink pad and the main cylinder cover, or the water chest cover in this case. Cut out the centres, punch the holes, and then finally cut out the shape of the gasket. And once I'd done all this, for the second time, I put the water chest back together, and the good news is it didn't leak. And it did pump water into the tank with a good bit more pressure when I put my finger over the pipe, but the minute that I shut the bypass valve, it refused to pump against boiler pressure. So what is the problem, I wonder? Inside this water chest there are 8 water valves, 4 for the inlet and 4 for the outlet. These valves are the same shape as valves used in cars, and they sit over a hole and they ground into the hole so that the seat of the valve matches the seat in the hole. So what can possibly go wrong? Why aren't the valves working? So I got a magnifying glass out and I had a look at the valves, and then I saw one of the problems. Some parts of the valve seatings, not on all the valves but on some of them, were sort of eaten away. Now I wonder what kind of acid would eat into brass. I'm no expert, but maybe it's the acid that's present in silicone rubber. I really don't know. I do know that when silicone rubber is curing, going off, setting hard, there's a very strong smell of vinegary acid. So I dismantled the pump once again, and then I reground the valve seats on all 8 of the valves, and put it back together, making 2 new gaskets in the process. And guess what? When it was all back together and working, I could pump some water into the boiler against boiler pressure for about 30 seconds. So it's time to take the pump further down. I took the next layer of the pump off, and surprise, surprise, I found massive amounts of silicone rubber in there too. I didn't think this would have been taken off in the first place, but yes, it had been. So I'm going to attempt to remove all traces of the silicone rubber from this pump and see what happens. And this is easier said than done. By this time my brain was starting to malfunction. As you can clearly see, I'm scraping off the silicone rubber residue and then using an airline to blow it away. It took quite a lot longer to do this than it's shown on the video because that's at high speed. And even worse is yet to come. Look at this. This is the main part of the valve chest. And you can see how close the silicone rubber is to the valves themselves. This is not good. All the valves are quite free in the holes, and as I've thoroughly ground in the valves 4 times so far, I'm sure that they're seating okay. By the way, you can see a stud in the hole at the left hand side. It's not broken, it hasn't snapped off. As I undid the nuts on the top of the water chest, it just unscrewed from the main casting. Most of the silicone rubber has gone, and after rubbing this part on a piece of 400 grade wet or dry sandpaper, I really am hoping I've got rid of all the particles of silicone rubber. And once again, I need to make some new gaskets. I wish I had a set of these. I think this is about the 5th time this pump's been down, so that's the 5th set of gaskets. I don't show everything on the videos. And I don't show when I bang my head on the wall of the workshop. Nor do I show it when I sort of cry, or go into the garden and have a primal screaming session. I even went up to Blackgates Engineering and bought a piece of thin gasket material. Even though the gasket material was thin, it wasn't thin enough, so I went back to the paper idea. But I decided not to use the recycled brown paper because it's not very good at all. And this is some paper that I got from my daughter Charlotte, and it's very good quality stuff. In order to fully seat this bottom block of the water chest, I used a soft hammer to tap it into position. So the combination of the good quality paper, covered in steam oil and tapped into position, should be okay. We shall see. At least it's not covered in silicone rubber anymore. All I need to do now is fit these 6 6BA nuts again. This is the 6th time I've done this. That's once for each nut on top of the water chest. I have a good idea what's actually happening inside the water chest to make it not pump water against pressure, but it's a difficult fix really. And the problem is that there are quite a few particles of silicone rubber still left in the water system. I've flushed the tank 5 times, and each time I've got some more tiny particles of silicone rubber because what I think happened was, when the excessive amount of silicone rubber was splurged into the water chest, it wasn't given time to cure fully before the engine was run. So the water carried some pieces of silicone rubber around the system, so there will be silicone rubber down in the main cylinders. It's time to try it now, and some water's gone up the glass. Now this is a very good thing. And the pressure now coming out of the bypass valve is good, really good. I can hardly stop it, but the point is, with my finger I can stop it, and I shouldn't be able to. I think at a future date this pump is a candidate for a complete rebuild, and it would be a ground up rebuild on the water side. The steam side is fine, no problems at all. It's just the water and the silicone rubber issue. With this type of valve, the mushroom type poppet valves, it's not like a ball valve. They will generally be quite forgiving and let particles through. But if any particle of silicone rubber, however small, lodges between the valve face and the mating face on the block, then it's going to let water through, and it's not going to get any better. And that is it for this video about a popular problem with miniature steam engines and pumps. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.